Okay, now I will show you some experiences from the past with the FDT container component. In a previous version of this slide set, there was something like issues and experiences, but I was asked to remove issues because it sounds better to say only experiences. Okay. Challenges.
Opportunities.
So the experiences we will browse over here are experiences really from the last, let's say, 6 or 7 years. Because as I mentioned before, 2004, 2005, we decided to use FDT DTM as the device integration technology in Schneider. And in 2005, 2006, we started to integrate the FDT containers into applications, or we started to develop new FDT frame applications. So these can be real old experiences, let's say. So first of all, it sounds maybe simple and stupid, but it's really from our point of view, an important point for development efficiency. If you want to integrate the FDT container component, do it not without direct contact, without direct help from M&M, because it really helped us a lot to have a direct contact with the developers at M&M to integrate the FDT container component very fast. At the beginning, you have a very complex scenario. FDT DTM is very new for the developers. The FDT container component is new, and it helps a lot to have a direct access to the M&M support. And one of our product departments made the error to start a development during summertime or during Christmas time. I don't remember exactly, but it was not a good decision because also M&M developers have the chance to make vacations, and then we had no direct access to the support. As I mentioned before, one of our applications was a native C++ application, and I think up to this time there was only a few experience available about the integration of the FDT container component into C++ applications, and because of that we had some difficulties to get the container component integrated into our C++ applications. Also, because the tutorial for C++ applications were missing, and we really had some debug sessions together with M&M to understand the interop problems between the FDT container component and our C++ application. So we had
these problems driven by the component interfaces, or the memory consumption, or something like that?
No, I think it's were really COM interoperability problems between the COM world on the C++ side and the .NET world. Yeah, this is where we had to struggle for some time, but nevertheless, together with the M&M support and with some debug sessions, we are now in really good shape in regard to this integration of FDT container into our C++ application.
Would you say that the problems were located in the FDT container component and they are solved now for our other companies that will try to integrate it in a C++ component, or were the problems you had and M&M tried to help you and now you're done with the job?
It's difficult to say, but finally I would say I think it's, to be honest, it was more or less on our Schneider side, the difficulties. And at the beginning it was a problem of understanding the interoperability problems between C++ and .NET because of missing experiences about this. But I would not say that a lot of bugs or issues were in the FDT container components. This was not the case, but nevertheless you can benefit from the experience, I think, because maybe some things were also done in the FDT container component. But I think
no more additional interfaces we asked for to have a better behavior on the memory management. Because the Unity tool is a very complex system. It's 10 years old. And it's a huge software, and it's not so easy to change them. Things like the new concept need to be integrated with FDT, because we go far more with FDT here. We also use the new interfaces which were defined for factory automation, so we automatically build from the process channels, we automatically build variables in the 1131 environment and things like that. So we have some visual interfaces implemented with private interface. So that are the main reasons, because it's not so easy to handle this huge software package. In this old C++ environment.
Okay, light documentation of a software is always a problem. I think this is nothing very new. I think for version 2 of FDT container component, this problem does not exist any longer. For version 3 now, for FDT2, I think we are working hard on getting also a good documentation, but it's no special problem. It's always the same with the documentation of software. Of course, software developers are always or very often complaining if they have to work with black boxes, with other software components where they don't have the source code and where they are not able to debug into. And this was also the case here during the container integration. On one side, our system application developers had the FDT container component, which was in the first step only a black box for them. They had no opportunity to see what is going up inside this component. And on the other side, they had the DTMs delivered by partners, by other product departments or whatever, which were also black boxes. And the container developers were complaining that they have really difficulties to debug and to find out where the problem comes from if they were faced with problems. Then at the beginning we had some setup problems with the FDT container component. At the beginning sometimes the versioning was not 100% consistent, or maybe it happened that the same version number was used for a different version of the components, but also I think more or less normal during software development that such errors are happening. We had a problem during the setup that if you changed something in the frame application in the system provided by Schneider itself, also the FDT container required a new installation, but all these problems were fixed. Then we spent some time trying to understand the configuration file of the FDT container component. There is a configuration file where you can, for instance, change the threading model of the FDT container component. And for our developers, it was not clear what is the impact on the different of the different settings on the system. So they spend a lot of time to trying out what threading model, what is the best for their application. but finally it turned out that it's, to be clear and honest, useless to change the default setting for the threading model. It's more for debug purpose or something like this, but for the final application it was not useful to change the threading model in this configuration file, and there were other settings, and the developers were checking these settings and spent some time for this. Then there were there are still some problems when you close an GUI, a graphical user interface of a DTM. We had some threading and timing problems. Maybe as a developer you see it still today sometimes when there pops up a dialog, UI is not responding, do you want to force to shut down the UI? So it turned out that the closing of a GUI is sometimes a bit tricky, but it's not 100% clear if it's really a frame problem or a DTM problem. Very often it's a DTM problem, but nevertheless we had some difficulties and we spent some time. The FDT container component is providing also some example code, a mini frame application which demonstrates the usage of the FDT container component. We tried to reuse some code from this mini frame, but for instance persistence mechanism used in this mini frame seems to be very complex and the performance was not good enough. So we decided to develop our own persistence mechanism, but I think this is usual because every company has an own persistence mechanism most of the times, or if you are integrating the FDT container component into an existing application, the existing application has already a persistence mechanism and you do not reuse the example code from M&M, of course. Smaller point, the code to create the menu from a DTM, from a device DTM, was very complex. Maybe it's also due to the FDT1 specification that there were some difficulties, but nevertheless, developers complained during an interview about their experiences that this was also very complex to handle, to set up the menu, the context menu for a device DTM. And we had the need in our systems to limit the number of open DTMs at the same time. This is due to memory consumption mainly. So if you have a system where you have 20, 50, 100, 200 devices integrated, and you want to configure all these devices, and you are trying to open 50 DTMs at the same time, and one DTM consumes 50 or 100 megabytes of memory, it will not work. So we had to implement a mechanism to limit the number of open DTMs at the same time. Even there was an example implementation in the FDT, or there is still an example implementation in the FDT container. In the real application, it's really hard to implement such a mechanism, because you have to decide when is the right time to close a DTM, or are there some pending changes in the DTM? Am I able to close this DTM now because I need the memory and the memory consumption is now too high? So in practical life, this is really a difficult task.
I got a question about that, because as a user interface, who would actually have 50 DTMs open at one time trying to do something? isn't there kind of a practical limit to what they can do? So, I mean, you know, if they were, or do they open them and then not do something and then not close them and then open another one and do something and not close them? I mean, it would seem to me, even if you had 100 devices available in the project, you would only open a few at a time.
Yeah, unfortunately, the end user makes a double click on the device, opens the UI of a DTM. Most of the times he doesn't know that he is using a DTM. He is using a configuration screen for a device. He is changing something, and then he goes again to the browser and opens the next DTM and the next and the next and the next. Okay. And this is what is happening with a simple user in the field, unfortunately.
Maybe our users will do the same thing, so I might have to think about that.
Okay, we have two things. So we have, on one hand, we have this Unity system, which itself has a huge amount of memory consumption before you start any career. It's a 32-bit application, so you cannot increase the accessible memory as much as you would like to do. And on the other hand, we had a drive DPM, which were also a bit implemented without consulting us or others. Not invented here syndrome. They had, I don't know, hundreds of megabytes at the beginning for one device.
Oh.
Yeah, I will come to this in one of my next slides, I think. So, okay, other experiences, of course, I told already. The FDT standard itself, at least the FDT1 standard is a complex standard for a beginner, for a new one. And sometimes it was also hard for our developers in Schneider Electric to understand the dependencies between the FDT container component API and the FDT state machine, for instance. So what method call at an API of the FDT container component causes what state machine change in the FDT state machine. This was sometimes not very clear for them, and they had to contact finally the M&M support to understand this.